Yes. So this is my 19th video on non-differential equation in the playlist of UPSC Math Optional. So far what we are doing is in the last video I have started solution of second and higher order differential equation with constant coefficient type 4, right? So RHS will be of the form e power ax sin x or e power ax cos ax or e power ax into x power n, right? So x power n is a polynomial equation in x. So we have solved 6 problems based on this type. So in this video we'll continue solving this problem. If you haven't watched the previous videos, you please watch previous videos, then only you understand this video, right? Yeah. So now we'll move on. Actually, we have solved in type 4, we have solved 6 problems. So we are going to solve more problems on type 4 because it's very important problem in a UPSC point of view. So you can expect a question from this type every year. So we're going to solve the 7th problem, right? Yeah. So 6 problems we have solved only on type 4. So now we'll move on to 7th problem. So which is solve d cube minus d square plus 3d plus 5 of y equal to e power x cos x. E power x cos x. Now you can see it is a third order equation with constant coefficients, and you can see it is type 4 because the RHS is of the form type 1 into type 2 e power x into cos x. So first we need to find the general solution. So therefore the general solution is y is equal to complementary function plus particular integral. So we need to find this solution, right? Yeah. So first we will find the complementary function. For that we need to find the auxiliary equation. So auxiliary equation is m cube minus m square plus 3m plus 5 equal to 0. Now it's a cubic equation, right? So first we need to find one root, then we can solve another two roots using the L method. So you can clearly see if m is equal to minus 1, this equation will be minus 1 cube minus 1 square plus 3 into minus 1 plus 5 is equal to 0. So it will be minus 1 minus 3 plus 5 equal to 0. So therefore this will be equal to 0 because minus 5 plus 5 is equal to, therefore minus 1 is one of the root. Minus 1 is one of the root. So we can find another two roots using L method. So you can say coefficients are 1 and this is minus 1, this is 3 and this is 5. So we have found that minus 1 is one root. So first you have to start with 0. 1 plus 0 is 1. Minus 1 into 1 is minus 1. So minus 1 you have to add here. So it will be minus 2. You have to multiply here. Minus 1 into minus 2 is plus 2. 3 into 2 is 5. 3 plus 2 is 5. Minus 1 into 5 is minus 5. So this will be 0. Now this is the coefficient of m square. This is coefficient of m. This is the constant term. So if we frame this equation from here, we will have m square minus 2m plus 5 equal to 0. Now we solve this quadratic equation to find the another two roots. So therefore m is equal to minus of minus 2 plus or minus square root of b square minus 4ac divided by 2 into a. So this will be 2 plus or minus square root of 4 minus 20 by 2. It will be 2 plus or minus 4i divided by 2 because roots this will be square root of minus 16. So I can write this as 4i. So if we take 2 common here, we'll have 1 plus or minus 2i. So the roots are minus 1 and 1 plus or minus 2i. So these are the roots. Now we need to write the characteristic function. Now you can see this root is a distinct root. So we will have c1 e power minus x plus, now you can see this is a complex roots, imaginary roots, and we know this is it is e power alpha x. So alpha is 1 into x into c2 cos beta x plus c3 sin beta x. Right? So don't think I am just writing as it is because I have explained more in the previous videos. So this is c1 e power minus x plus e power x into c2 cos 2x plus c3 sin 2x is the characteristic function, right? So if you haven't watched the previous videos, you have to watch the previous videos. So we know if the roots are imaginary, if it is of the form alpha plus or minus I beta, then characteristic function will be e power alpha x into a cos beta x plus b sin beta x. So here a and b are just arbitrary constants. We can write as you like. So we can C2 C3 here. So if you compare this with alpha plus or minus I beta, here alpha is equal to 1, beta is equal to 2. So that's why I written alpha in place of 1x and here I written 2x. Now we need to find the particular integral. This is very important. So we need to find the particular integral. So this will be 1 by d cube minus d square minus 3d plus 5 of e power x cos x. Now this is the first step, right? In order to write the particular integral, 1 by d cube minus d square minus 3d plus 3d actually it is minus 3d or plus 3d. Yes, plus 3d plus 3d plus 5 e power x cos x. Now this is we are in type 4. So our first step will be replace d by d plus 1. Now we can take d power x outside, right? So we have to write, if we have e power x into something, we have to replace d by d plus a. That is what I said in the previous video. So here e power x will now be taken outside and we have to replace d by d plus 1. So this will be d plus 1 whole cube minus d plus 1 whole square plus 3 into d plus 1 plus 5 into cos x. So you have to simplify this. So e power x into 1 by a plus b whole cube is a cube plus 3a square into b plus 3ab square plus b cube minus, so a plus b whole square is a square plus 2ab plus b square. So since you have minus here, the whole term will be minus d square minus 2d minus 1 plus 3d plus 3 plus 5 of cos x. Now this will be e power x into 1 by, so d cube. So here we will have 3d square. So again here we have 1d square. So overall 3d square minus d square will be 2d square, right? So d cube plus 2d square, and if you collect all d terms, so this is one d term and here is one d term and here is one d term. So 3d minus 2d is d plus 3d is 4d, and if you collect the constant term, so we have 1 minus 1 is 0, 1 minus 1, so 5 plus 3 is 8, 5 plus 3 is 8, right? Yeah, into cos x. Now we'll mark this equation as 1 and we apply type 2 to here and then substitute here, right? Yeah, so we need to apply type 2 here. So first consider a, right? So I'm going to apply type 2 here and then I'm going to substitute last in this answer. So it is 1 by d cube plus 2d square plus 4d plus 8 cos x. Now what I can do is, so for type 2 I have to replace d square is equal to minus a square, right? So replace d square is equal to minus of a square. So this will be minus of 1 square. This will be minus 1. So if I do this, you can see this, I can write this as d into d square plus 2d square plus 4d plus 8 of cos x, and I can replace d square is equal to minus 1. So this will be minus d, and if I substitute d square is equal to minus 1, this will be minus 2 plus 4d plus 8 cos x. So this will be 1 by, so 4d minus d is 3d, 8 minus 2 is 6 cos x. Now we can do this very easily, right? Now I will take the conjugate. So before that I can also take 1 by 3 outside and this will be 1 by d plus 2 cos x. Now you have to take the conjugate here. So you can see it is type 2 case 2. So if you take conjugate d minus 2, this will be d plus 2 into d minus 2 cos x. So I'm just taking conjugate d minus 2, d minus 2. So this will be 1 by 3 d minus 2 of cos x divided by d square minus 4. That is a plus b, a minus b, a square minus b square. This will be 1 by 3 d of cos x minus 2 cos x divided by, so d square is minus 1, so minus 1 minus 4. So this will be 1 by 3. So derivative of cos x is minus sin x minus 2 cos x divided by minus 5. So if I can take minus outside the numerator, so we'll have 1 by, so 5 3s are 15. So we take minus outside here, this minus will get cancelled. So we have sin x plus 2 cos x. Now this is the answer for this, right? So now equation A becomes, hence equation A becomes, so the particular integral will be e power x into 1 by 15 sin x plus 2 cos x. Now you can write general solution to be, the general solution is y is equal to complementary function plus particular integral. Now you can add up both the answers. So we have found particular integral, we have already found the characteristic function or complementary function. So I'll move on to the 8th problem. So we'll continue the next problem. It's a very important problem. This question asked in IAS 993. So solve d power 4 plus d square plus 1 of I is equal to e power minus x by 2 cos root 3 x by 2. Right? Yeah. So we already solved this auxiliary equation in the previous videos. So first, the general solution will be, y is equal to complementary function plus particular integral. So first we will find the complementary function. So for that we need to write the auxiliary equation. So we need to solve this equation. M power 4 plus m square plus 1 is equal to 0. Now I have already solved this equation, I think. I solved this, but don't know where I solved, whether type 2 or type 3. M power 4 plus m square plus 1. We'll see whether in type 2 we have solved. Yes, here it is, I think. M power d power 4 plus d square plus 16. So here we have d power 4 plus d square plus 1, right? The only thing is the constant term is changing here. So if you have watched this video also, you know how I did this problem, right? Suppose I try to solve this using put t is equal to m square, but I arrived at the square root of a complex number. So I tell you the Aliter method. So I tell you a shortcut of how to solve when we have d power 4 plus d square plus some constant term, right? So I'll just show you how I solve. Yeah. So you can see I splitted this equation as like this, and then we have solved separate equations. So how I did is, so here we have 16. So 16 is the square root of 16 is 4. So we have m square plus 4 whole square minus. So you just expand this. So we'll have m power 4 plus 16 plus 2ab. So 2ab is 8m square, but you have only 1m square here. So you just adjust with this term. So that you will get m square here. So we'll get 8m square here. So you have to subtract 7m square to get 1m square. So that's why I'm writing this as m root 7 whole square. So this will be 7m square, right? So same way I'm going to write this equation also. So here we have m power 4 plus m square plus 1 is equal to 0. Sorry. m power 4 plus m square plus 1 is equal to 0. Suppose you will write this as m square plus 1 whole square. So if we expand this, we will have m power 4 plus a plus b whole square formula, right? So 2m square plus b square. But here you will have m power 4 plus 1 we have. But here we should have 1m square. But here we will have 2m square. So we will subtract 1m whole square. That's it, right? So now we can expand a square minus b square formula like this, and then you solve this two equations separately. Now we'll find the roots, right? So only thing is you have to, first thing is you identify whether we solved these types of problem in the previous video, right? Then you can solve any problem in your own. So how I'm going to write this is, so I can write this as m square plus 1 whole square minus m square, right? That is what I have discussed so far. So here a square minus b square. So it is m square plus m plus 1 into m square minus m plus 1, because m plus 1 plus m plus 1 minus m. So I'm just interchanging this term straight away, is equal to 0. Now we solve this equation separately. So now we solve for m square plus m plus 1 is equal to 0, or m square minus m plus 1 is equal to 0. Now I think you can solve this separately. So m square plus m plus 1 is equal to 0. So here the roots are minus 1 plus or minus b square minus 4ac divided by 2 into 1. Here the roots are minus of minus 1 plus or minus square root of b square minus 4ac divided by 2a. So here we will have minus 1 plus or minus, so this is minus 3 here we will have, so 3i by 2. So here 1 plus or minus 3i by 2. Remember, these are not equal roots. Here we have minus 1 plus or minus 3i, but here only 1 plus or minus 3i by 2. Now we can write the characteristic function. So our characteristic function will be, since you have 4 roots, so first you write characteristic function for this. So it is an imaginary root. So this is of the form alpha plus or minus I beta. So here alpha is minus 1 by 2, beta is root 3 by 2. Here alpha is 1 by 2, beta is root 3, right? Root 3. Root 3, beta is root 3 by 2. So I can write away, I can clearly write away the equation. So e power minus alpha x, e power alpha x, so alpha is minus 1 by 2 into x into a c1 cos beta x plus c2 sin beta x. Use the characteristic function for these two roots, plus again I'm going to write this for this characteristic function. So here we will have plus 1 by 2x. So here we have minus 1 by 2x into c3 cos root 3x by 2 plus c4 sin root 3x by 2. Now this is the characteristic function. Now we are coming into the important case, the particular integral. So it is given to be 1 by d power 4 minus d square plus 1, right? D power 4 plus d square plus 1 into the RHS is e power minus x by 2, e power minus x by 2 cos root 3 x by 2, right? So first you have to replace d by d minus 1 by 2, because here a is minus 1 by 2. So now what you can do is you can bring e power minus x by 2 outside. Now we have to replace d by d minus 1 by 2 whole power 4 and d minus 1 by 2 whole square plus 1 into cos root 3x by 2. Now you can apply type 2 here. So for that, first you have to simplify this denominator. So d minus 1 by 2 whole power 4. So for first I simplify this denominator and then I apply here. So first you simplify this denominator, d minus 1 by 2 whole power 4 plus d minus 1 by 2 whole square plus 1. So first we know that a minus b whole power 4 is equal to a power 4 minus 4 a cube b plus 6 a square b square minus 4ab cube plus b power 4. Now you have to expand this term plus 1, and then you have to simplify this. So when expand this term, so we will have d power 4 minus 4 into a cube into b, right? 4 into a cube into b plus 6 into a square into b square minus 4 into a into b cube plus b power 4. So b power 4 is 1 by 2 whole power 4. So this is the formula for a minus b whole power 4 formula. Plus here I can expand this. So it is nothing but a minus b whole square formula. A square minus 2ab plus b square plus 1. Now I need to simplify this to get the required answer. So first what we will do is we will collect only the d power 4 terms. So we have only one d power 4 term. So I can write this to be, so I will write away here. So e power minus x by 2 is outside. So here we have only one d power 4 term. So if I collect the cube term, so here there is one cube term and I think no cube terms, right? So there is only one cube term. So I can write this as so I can cancel this 2. So 2 ones are 2 twos are. So we will have minus 2d cube. Now we have to collect the d square term. So you can see there is here is one d square term and here is one d square term, right? So here we have 2d square term, which is 6d square 1 by 4 and 1 by 2 square is 1 by 4, and here we have 1d square term. So we cancel 2 2s are 2 3s are. So 3d square by 2 plus d square. So 3d square, this is nothing but 5d square by 2, right? So 5d square divided by 2 plus I need to collect the d terms. So I think it is very easy. So we can do this very easily, right? Now I need to collect the d term. So how many d terms are there? So there is, this is here one d term, here one d term. So here we have minus 4d into 1 by 8, and here we have minus 2d into 1 by 2. I can cancel 2, can cancel 2 here. So we will have minus d by 2 minus d. So we will have minus 3d by 2, right? So minus 3d by 2. Now we need to collect the constant term. So we need to collect the constant term. So here 2 constant term and here is 1 constant term, right? So this is 5 by 4. So 5 by 4 plus 1 by 8. So 1 by 4 plus 1 is 5 by 4. So 5 by 4 plus 1 by 8. So here the LCM is 16. So into 4 into 4 into 1 into 1. So we'll have 21 by 16 into cos root 3 x by 2. Right? Yes. So I mark this equation as A. Now one important thing is you need to apply type 2 here and then we need to substitute in A. So we need to apply type 2 to here, which is 1 by d power 4 minus 2d cube plus 5d square divided by 2 minus 3d by 2 plus 21 by 16 cos root 3 x by 2. So we will apply type 2 here. So in order to apply type 2, we have to replace d square is equal to minus of a square. So here a is root 3 by 2. So this will be changed to root 3 by 2 whole square. So this will be minus 3 by 4. Now I can write d power 4 as 1 by d square into d square. I can write d cube as d into d square plus 5 by 2 d square minus 3d by 2 plus 21 by 16 cos root 3 x by 2. Now you just replace wherever you have d square, you just substitute d square is equal to minus 3 by 4. So here you have minus 3 by 4 minus 3 by 4. So minus 3 by 4 minus 3 by 4 is 9 by 16 minus 2d. So d square is minus 3 by 4 plus 5 by 2 d square is minus 3 by 4 minus 3d by 2 plus 21 by 16 cos root 3 x by 2, right? Yeah. Now what I can do is you just collect the constant term and the d term. So because you have only two powers here, one is constant term, another is d term. So you can see this will be plus 6d by 4 minus 3d by 2, and to collect the constant term you will have 9 by 16, and this will be minus 15 by 8 plus 21 by 16 into cos root 3 x by 2. Now you can see the denominator becomes 0 because 2 2s are 2 3s are. So 3d minus 3d minus 3d by 2 minus 3d by 2 is 0, and we take LCM for this, we will have into 1 into 1 into 2 into 2. So this is 9 plus 21 is 30, 30 minus 30. So again it is 0. So you can see this whole term, this denominator becomes 0 cos root 3 x by 2. So if you have watched the previous video, the denominator becomes 0. What you need to do? You need to multiply x and then we need to differentiate the denominator. So when I differentiate this denominator, so here we have d power 4. So d power 4 is 4d cube. So remember, these are very easy problems. You can do this in your own, right? So 4d cube, and I need to differentiate 2 minus 2 into d cube is 3d square. So we will have minus 2 into d cube is 3d square, and again you differentiate, I can take 5 by 2 outside. If we differentiate d square, we will have 2d. So 5 by 2 into 2d plus 5 by 2 into 2d, and if I take minus 3 by 2 outside, derivative of d is 1. So minus 3 by 2, this will be constant 0. So we will have minus 3 by 2. So we will have minus 3 by 2 into cos root 3 x by 2, right? Yes. Now what I can do is, so this is nothing but x into 1 by 4d cube minus 6d square, this is 6d square, this 2 will get cancelled. So we will have 5d minus 3 by 2 into cos root 3 x by 2. Now again you have to replace d square is equal to minus of a square. So again you have to replace d square is equal to minus 3 by 4. So if I do that, so this will be x into 1 by 4 into, so I can write d cube as d into d square. So in place of d square I can write this as minus 3 by 4 minus 6 into d square is minus 3 by 4 plus 5d minus 3 by 2 cos root 3 x by 2. Now this 4 get cancelled. So we have x into 1 by, so this will be minus 3d, right? So minus 3d plus 5d is 2d, and here we will have, if I cancel 2 2s are 2 3s are, so we will have plus 9 by 2 minus 3 by 2 into cos root 3 x by 2. So this is nothing but x into 1 by 2d minus 6 cos root 3 x by 2. Sorry, here you will have 6 by 2 is 3, right? So 2d plus 3. So 2d plus 3 cos root 3 x by 2. Now we need to, now we can easily do this, right? Because this comes under type 2 subcase 2. So here we want to take the conjugate. So the conjugate is 2d minus 3, right? So 2d minus 3 divided by 2d minus 3 into cos root 3 x by 2. Now this I can write this as x into 2d minus 3 cos root 3 x by 2 divided by, so this I can write this as a plus b, a minus b, 4d square minus 9. So again you have to replace d square is equal to 3 by 4. So this will be x into 2 of d of cos root 3 x by 2 minus 3 cos root 3 x by 2 divided by 4 into, so d square is minus 3 by 4 minus 9. So I just multiplied 2d and minus 3 inside. So we have to differentiate cos 2. This I can cancel. So I can take minus 12 outside. So we will have minus x by 12 outside. And if I differentiate this, we will have derivative of cos is minus sine root 3 x by 2 into root 3 by 2, because I'm differentiating, right? So this will remain as it is, minus 3 cos root 3 x by 2. Now I can cancel this 2 and this 2. So if I take minus outside, so this both the will get plus, and this minus will get cancelled. So we have x by 12 sine root 3 x by 2 into root 3 minus 3 cos root 3 x by 2 is the required particular integral. You can also simplify this to some more extent. For example, you can write 12 as 4 into 3, and you can bring 3 inside. So we bring 3 inside. Here we have by 3, here we have by 3, and this 3 will get cancelled. So here we have denominator 3, so you can write this as root 3 into root 3, and then you can cancel root 3 here. So you can do this. You can also do simplification also, but I'll stop at this. So this is the particular integral. So therefore, the general solution is y is equal to complementary function plus particular integral. So therefore, you can write this as the answer. Remember, this question asked in 15 marks or 20 marks, I don't know, but this is asked in IAS 1993. It's a very easy problem. The only thing is you have to find the complementary function and the particular integral. Then you are done with the problem, right? As simple as this. As simple as this. Okay, right? So let me continue the next video. I'll do one more problem. Yes, so we will solve this problem and then finish the video. So this is also asked in IAS 1998, right? This question is also asked in IAS 1998. So it's a very easy problem. The first thing is you have to first fix the topic. So it is a second order equation with constant coefficients, and you can see the RHS is e power 4x into type, that is type 1 into type 3. So first, the general solution is y is equal to complementary function plus particular integral. So first we will find the complementary function. For that we need to find the auxiliary equation. So it is m square minus 5m plus 6 is equal to 0. So this question can also be asked like d square minus 5d plus 6y is equal to something e power 4x into x square plus 9. Both are same. So first we will find this. So I think you can do this very easily, right? So m square minus 5m plus 2x. So therefore this is nothing but m minus 2, m minus 3. So you can factorize this. So therefore the roots are real and distinct. The roots are real and distinct. So therefore the complementary function will be c1 e power 2x plus c2 e power 3x. Now we need to find the particular integral. So this is 1 by d square minus 5d plus 6 e power 4x into x square plus 9. Now I can replace d is equal to d plus 4, so that I can take e power 4x outside. So we will have e power 4x outside. So here we will have d plus 4 whole square 5 into d plus 4 plus 6 x square plus 9. Now we have to apply type 3 here, right? So type 3 will be RHS is of the form x power n, that is a polynomial equation in x. Now first we will simplify the denominator and then we will apply type 3. So a square plus 2ab plus b square minus 5d minus 20 plus 6 x square plus 9. So if I simplify this, we will have e power 4x 1 by d square. So 8d minus 5d is 3d. 16 plus 6. So 16 plus 6 is 22. 22 minus 20 is plus 2 x square plus 9. So we will mark this equation as A. Now what we will do is we will find the particular integral under case 2. So first we will solve 1 by d cube 1 by. So now consider 1 by d square plus 3d plus 2 of x square plus 9. So you know how to solve this equation, right? So first you have to take the least degree outside. So I'm just using this solving this under type 2, sorry, type 3. So if we take least degree outside, we will have 1 by d square plus 3d by 2 of x square plus 9. So put capital X is equal to, remember I'm just follow, if you have seen the previous videos, you can do this sum in your own, right? So please watch previous videos and come back to this video. So this will be, I can take 1 by 2 outside. This I can write this as 1 by 1 plus capital X of x square plus 9. So this I can write this as 1 by 2 1 plus x whole power minus 1 of x square plus 9. So if I expand 1 plus x the whole inverse, so this will be 1 by 2 1 minus x plus x square minus x cube and so on of x square plus 9. And if you multiply x inside, so we will have 1 by 2, so this will be x square plus 9 minus capital X of x square plus 9 plus capital X square of x square plus 9 and so on. Now here you can see our RHS is x square plus 9. The first derivative will be 2x plus 0, and second derivative will be 2, and third derivative will be 0. So we don't need to find d cube and other terms. So we can stop only at d square. Now we will replace x is equal to d square plus 3d by 2. So this will be 1 by 2 x square plus 9 minus, so if we replace x is equal to d square plus 3d by 2 into x square plus 9 plus d square plus 3d by 2 whole square into x square plus 9 and so on. Now what I can do is this 1 by 2 x square plus 9. If I differentiate this, so we'll have 1 by d square of x plus 9 minus 3 by 2 d of x square plus 9. So if I expand this, so first you will have a square. So a square is d power 4, so we don't need to write that term. And 2ab is d cube term, so we don't write the term. So it is enough to write only b square term. So b square term is 3d by 2 whole square, so which is 9d square by 4 into x square plus 9, right? So I'm just neglecting d cube and higher term. So we have only one term which is d square here. So 3d square by 4. So therefore, so this will be 1 by 2 x square plus 9 minus 1 by 2. So double derivative of x square plus 9. So which is nothing but 2 minus 3 by 2. The first derivative of this is 2x. And again the double derivative of this is 2. Now I need to simplify this. So we will have 1 by 2. So this 2 will get cancelled. So we will have x square minus 3x. This 2 will get cancelled. So 2 1s are 2 2s are. So we will have 9 plus 9 minus 1 plus 1 by 2. So 8 plus 1 by 2. 8 plus 1 by 2. X square minus 3x. So whether I missed some terms, or 9 by 4 to 2, 9 by 2. So just 9 by 2. 9 by 2. So this will be 1 by 2 x square minus 3x. So this is 8 plus 9 by 2. This is 25 by 2, right? So plus 25 by 2. This is the particular integral for this. So but what we need to do? So therefore the particular integral is from a. So we need to multiply e power, what's the question? So we have to multiply e power 4x to this term. So when I multiply e power 4x to this term, we will have e power 4x by 2 x square minus 3x plus 25 by 2 is the particular integral. right? So therefore the general solution will be y is equal to complementary function plus particular integral. So just add up the complementary function and the particular integral. That's it, right? So we'll continue solving more problems on type 4 because this is very important. So you also continue solving some problems. You take some standard books and then try to solve in your problems in your own, right? That's it. We'll see in the next video. Goodbye. Thank you. And next video also we will continue type 4 problems, right? Yeah. So type 5 is very easy. So type 6 there's the combination of all. So we'll finish this in next 2 to 3 classes, and then we'll move on to the next topic, which is the variable coefficients, right? Goodbye.